like that. It can even be done by ourselves without using the computers, right? But the thing is, when we are using the computers, it has a very high speed. The accuracy is very high compared to the humans. And then it is having a capability of storing huge amount of data. So those are the reasons actually we are using the computers. So then, right, for performing these stuffs, we use the computers, and they're just performing some things for us, for actually making our life easier. But now I have a question. Right? When we have a software, right? If you're using this software for doing something, right? Let's say for doing some kind of a operation, I have a problem how the computer knows what to do. For example, let's say now here I have shown kind of a a kind of example. Let's think about kind of a photo editing tool. Let's say I have here increased the brightness, right? Let's say now this is my previous image, and let's say now it was just the brightness was a bit increased now. Now I have a question, right? How this brightness was increased. For an example, let's say there's a kind of a bar or something. When we, let's say, move this particular bar here and there, the brightness is changing. So how does this computer program know to increase the brightness? Let's say when we move this whatever the bar, right, brightness is increasing. So how the computer knows it? Is there any answer from anyone? I think you can use chat box, right? You can give some answers as you think. How does this computer know to increase the brightness? Let's say when we change the bar level here and there, but the brightness is changed according to that. My question is, how did this computer know to change the brightness? Any suggestion from anyone? So what I'm just doing here is I just want to build a kind of a discussion about the difference between a typical computer program and an AI program. To understand that thing, right, we should be having kind of a discussion like this. That's why I'm just discussing these stuff. So do you have any answer for this? You can use chat box and you can just give your thoughts. I'm asking, how does this computer know to change this brightness when we change the bar level? All right, this is the thing, right? The thing is, the computers cannot think it and do, right? Understood? Computers can't do it. What the computer is doing is, inside the software, the developers of the software, right? Yeah, the developers of the software have given the instructions, right? Instruction means, let's say, some kind of algorithm, right? Algorithm was written. So I hope now, in the previous session I did for you under the fundamentals of Python programming, right? You can actually check that recording, right? It is in the YouTube. So there I have clearly explained what is it meant by an algorithm, right? Okay, there are different ways that we can create the algorithms. We can simply create the program. So using a computer program, right? Programming language, sorry. Using a computer programming language, we can actually give some instructions, right? In a particular computer program to do something, right? Okay. So what actually happens is the developers, for an example, let's say the previous, if I talk about the previous example, the developers of this particular tool, right? They have given some instructions, let's say with some kind of programming language, to actually increase the brightness when the user is moving this bar. So what the computer does is, computer basically, right, follows the instructions given by the user and, right, does the thing, right, what it does. So basically increase the brightness. So that is the thing, right? You must understand. The computers can't understand. Computers can't basically think or make the decisions what to do, right? Computer doesn't know actually what is going on. So it is basically following the instructions and just do the required things. That's it, right? That is what basically, right? The particular reason behind, right, happening basically these processes, right? If I talk about any kind of a computer program, let's say the Word, let's say this PowerPoint, let's say this Zoom, in all of these, right, softwares, the developers of these softwares have written the instruction. But to actually write the instructions, we need the programming language. One programming language, let's say Python, Java, likewise languages are there, right? All right, that is what actually I have just mentioned. That the first thing is that you have to basically right, give the instructions. But when you are giving the instructions, definitely you have to communicate. You have to communicate with the computer. But when you are communicating with the computer, I think that this stuff we have discussed last time as well. So when you're actually communicating with the computers, in the computer actually we have, right, computers are having what? They are having basically these ones and zeros. Right? Computers can understand just these ones and zeros. Then definitely, guys, we should be having a mechanism to actually communicate. So we can't actually communicate with these ones and zeros. It's a very difficult thing, right? That is why we are using the programming languages, right? So I think that we discussed about the Python. You remember in the first session, actually, we comprehensively discussed how can we develop these things with the Python. And I think that in the second session, you learned about the web development. There you learned about some different programming scripting like languages like HTML and some supporting tools like CSS. And I hope that you learn about JavaScript and then PHP. And I think that in the MySQL, you learned about some declarative languages like SQL. So like that, okay? So different languages are there. But the language itself is not sufficient for doing something, because the language is kind of a medium that we can use for communicating with the computer, but we should be having an algorithm as well. Algorithm is the way actually how these instructions are ordered. What are the steps to be followed, right? One by one, right? In which particular step is happened after some step, likewise, right? That is what the algorithm means. So basically the combination of these programming languages and the algorithm is giving actually what we need. So what the computer does is, computer is following these algorithms, right, that which were developed by the users, and it's basically doing the thing what we have asked it to do, right? But it is not making any decision, right? It is not making any decision, right? So it is just following the instructions only, right? That is what a typical computer program is doing. I hope you got my idea, right? A simple computer program is doing what? That particular thing. Basically, following the instructions and giving the required output to the user, which was actually requested to be given by the developer. Right? Developer has written some instructions to give some kind of output. When the user is, let's say, requesting that particular output by, let's say, clicking a button, or let's say moving some kind of a, let's say, bar, or some kind of, let's say, graphical thing. So basically it gets some kind of signal. All right, if this signal happens, all right, do this. And what you have to do, it is written inside the program itself, the algorithm with one kind of programming language, right? That is the typical computer program is doing, right? Now that is the nature of a typical computer program, right? But now we'll try to understand, right? Now we'll try to understand what is AI. I mentioned in a typical computer program, what it does is basically it's following instructions and doing something. But in the AI, right, it's actually kind of a extension of these programming basic instructions based software. So let's say programs. In the AI, the additional part which is in the program is, in the previous case, developer of the software had decided, right? When a user, let's say, click this button, do this. That was actually thought by the developer. And so the developer of the software, he thought like that. And then he had written whatever the instructions. So when a user is clicking something or let's say doing some kind of a thing, so based on that, okay, do this. That is what the instructions are showing. So the computer had done this, that's it. But now what happens? Now, guys, rather than it's following just the instructions, in the AI programs, guys, we have given the program. We have given the program to the power actually to make the decisions. We have given the program to make the decisions, and based on that, right? Based on that, to basically right, do the whatever the right required right activity, right? So it is having the capability of making the decisions, and then based on the decisions that it had made, it can do something. That is what the difference between a typical computer program and an AI program. I have mentioned that thing here. So AI is having the ability of computer or machine to perform tasks that normally require the human intelligence, right? So previously, human had actually made the whatever the decision and perform. But now what happens? The AI program itself, right, has the capability of making the decision and performing the thing. So I hope now you understood the difference between the AI and a typical computer program, right? Okay, right. Okay, before we moving further, right? Before we moving further, can you please type yes in the chat box if you understood what I was talking about so far? Can you please just type yes in chat box if you understood so far? All right. Okay. So I hope you guys got my idea, right? My point. All right. Let's moving on. Come back to the slides. All right. So now I hope you now understood the difference between the difference between a typical computer program and an AI program. So what is basically we are just doing additionally here is we are just building an intelligence inside this program, right? Right. Now I have a question for you, right? You know that when I was just talking about this one, right? When I was talking about this one in the beginning of today's session, I mentioned computers can't think. Computers can't think, and it's just basically performing what we have asked it to do. But now I'm just telling the computer program is having now in the AI programs, the computer program is given, right? Given the power of making the decisions. And based on these decisions, it is doing something like, no, there's a kind of a contradiction between the previous thing and this one. What is that? Now, do you think the computers can think? What do you think? Because that if it has to make a decision by itself, definitely there should be some kind of a thinking process. Now, can the computers think? Can the computers can think now? Any idea from anyone? What do you think? Yes, I think some of you guys have given the answers. Still, dear students, the computers can't think. Don't get misunderstood. So in the AI programs, it doesn't say that we are just giving the power of thinking, right? It's not like that. So basically, because this is just a hard, so still that we are having the typical computer program that we had previously, right? Same hardware components, same chips, same memory, right? Uh, basically capacities and same things are there, right? Now what is happening? All right, this is the thing, guys. Still, guys, still, right? We are the actually we are the ones who are right building this in the program. So program is not actually building intelligence by itself, right? So we have to build it. We have to build it. Again, what? This is the thing, guys. Again, the intelligence is also what? It's a set of instructions, right? It's a set of computer instructions. That's the thing. So, but the thing is this: previously we had written the instructions to do something, right? Previously, we brought the instructions to do something, right? But now what happens is we have not given the instruction to do something. What we had done was we had basically, right? We had basically written the instructions to give the power to the program to make the decisions. That's the thing. Only thing is the way that we have given the instruction is different. Right? The way that we have given the instruction is different. Right? Now the instructions are there to make the intelligence inside the program. And then based on the particular intelligence, it gets based on our instructions. Again, we are the ones who have given the instructions. Guys. Otherwise, they don't think that a computer is having now superpower to make the decisions. No, we have to write it. We have to write it. Okay, this is how you have to make the decision. Right? We have to teach the computer. Understood? And then based on what the computer had actually got from my instructions to make the decision, right? It will make the decision, and based on that decision, all right, okay, we can ask the computer to do some kind of a operation. That's kind of an additional thing. Now, previously, that instructions, basically that decision was made by the developer, but now what happens? The computer has itself, right, made the decision, but how it made the decision? Again, based on our instruction. We are the ones actually who have given the instruction. So otherwise, the computer has not, right, built this instruction. That's the thing. I hope you got my idea, right? So I think that we have already learned about this one. AI is not robotics anyway, right? It's a kind of a different thing. It's a computer program actually. But like in other fields, robotics is also very seriously using AI. Because to build the intelligence inside a robot, we need what? AI. Right. So actually AI is what? It's a computer program. Right. Now tell me, who is this person? You know, the name is John McCarthy. And according to John McCarthy, he had mentioned the science and engineering of making intelligent machines. and especially intelligent computer program. And this was the definition which was given by John McCarthy to the AI, right? Anyway, who is this person, guys? Do you have any idea about this? Is there anyone who knows about this person? Right. Okay, John McCarthy. Actually, this is the person, guys, who had actually given the right name of AI to this particular subject area. He's the person actually who built this particular term, artificial intelligence. Right? He's the person actually who built this particular term, right? AI term. But don't get misunderstood, right? He's not the father of AI, right? What he did was basically he actually identified this particular subject area as a separate subject field, a separate science, and he actually gave this particular name as well to this particular science called artificial intelligence. Actually, he is called as father of modern AI, right? Father of modern AI, the person actually who sacrificed a lot to this particular subject area to build this particular subject area and gave this particular title as well, right? So actually, the particular person who is considered as the father of AI is Alan Turing. You know who is Alan Turing, right? So short while ago, actually, I mentioned about computing. The concept of the computing was also, for the first time in the world, right? The concept of the computing also actually introduced by the person called Alan Turing. He actually mentioned something called Turing machine. He invented the kind of a thing called Turing machine, and that was the first time actually we talked about something called computing, right? So the same person actually built this particular concept, but actually he didn't give this particular title to this particular concept. He didn't give any title. He just talked about kind of an area where the programs can behave without having the human support, basically making the decisions by themselves. But this is the person actually, guys, who had identified this thing as a completely separate area and gave this particular nice, beautiful name as well to this particular subject area. And then we call this person as the father of modern AI. But sometimes when you Google, sometimes in the Google, in some references, this person had actually identified as the father of AI as well. And there's no problem with that. But actually, normally we call something called father means the person actually who had found something for the first time. So if we talk about that one, actually Alan Turing was the first person who talked about this, the field where the intelligence is right inbuilt in the programs, but he didn't actually identify that thing as a separate subject. But this is the person actually who actually gave this particular title and identified this thing as a completely different area. Right. I hope now you got some kind of idea about this one. So basically, according to John McCarthy also, he had very nicely mentioned the AI is the science and engineering of making the intelligent machines, especially the computer programs. He had mentioned this is the computer programs. That is very important, right? All right, now this is the thing, guys. So I just mentioned, so basically in the AI programs, what happens is that it is having kind of a way of making the decisions. That is the thing. So it is having the way of making the decisions, right? So now we have a problem, right? So how can we make this decision making power inside the computer program, right? How can we make it, right? Because that is what actually the AI means, right? The power of making the decisions by the computer program itself, right? So you know that definitely to make kind of a decision about something, we should be having an intelligence, right? For making some kind of a decision by the computer program itself, definitely we have to build a kind of intelligence inside the computer program itself. right? Okay. So one way is what we can just build kind of a brain, but it's impossible, right? So we can't put a brain to the computer programs. So what then we do, right? That's the thing. That is why we call this as artificial intelligence. So what we try to do is we try to actually replace this particular, that as the human beings we have a capability of making the decisions. We have the intelligence, right? The computer, basically our brain is helping us to actually make the decisions, right, with our intelligence. So what we try to do is, right, we actually use some mathematical frameworks. Right? We use some mathematical frameworks to actually map the brain process in humans inside what? Inside the our computer programs. That's the thing. Inside the computer programs, we try to actually build that particular, right, brain mechanism inside the computer programs, basically using mathematical frameworks. That is what, right? So we actually discuss under the AI. So you must understand one thing, guys. So if you are having kind of ambition to come to the development of the AI, right? I think that we have most of the participants in today's session. I think that they are from the school children. I think most of you guys are school buddies. So if you have a kind of a, let's say, ambition to come to the AI field someday, right? There are two types of actually people who are working with the AI, right? The first type of people actually they are just using the AI. Nowadays that we have lots of AI tools, right? ChatGPT and Gemini, and let's say we have let's say um, Midjourney, like image generation tools, and let's say we have um, some 11 labs like audio processing tools, and we have some other tools. Lots of actually AI tools are there, right? So there are some people actually who are using these tools and doing something. So they don't actually care about what is happening inside the algorithm or what is happening inside the program. So they don't have to think about these mathematical things. They can just use it. But this particular session is not for those guys, right? This session I'm doing for the students who are actually having an ambition to build the computer AI based programs, who will be building these programs, right? Yes, you can use them as well. That's a separate case. But now I'm just talking to the students who will build, right? Build these AI programs. So then, guys, then you must actually use mathematics and those frameworks, because all the AI tools are actually, if I say go into the basically the architecture of the program, or let's say the brain of the program, it's basically maths, 100% maths, right? So this is kind of advice I just want to tell you, since most of you guys are school kids. If you are having a kind of a right ambition, or let's say a kind of a dream to become a kind of AI engineer who is going to build these AI programs someday. And if you are having a dream, if you are dreaming to, let's say, join with some companies like Google, Microsoft, and Meta, right? Likewise, OpenAI, likewise, some platforms, some companies someday, as an engineer who is going to build this AI, you must learn mathematics very well, and you must love mathematics very well, right? If you hate mathematics, dear students, unfortunately, this is not the field for you, right? Because this particular field is 100% depending on mathematics, right? It has lots of mathematics, right? Lots of very complicated uh, concepts under the mathematics, right? Because I mentioned, so what we try to do is we just try to build kind of intelligence. We can't build it without having mathematical concept, right? So that is the kind of advice I just want to tell you. So if you have kind of a dream of being a developer of the AI, again I'm telling guys, there's another group called AI users. So basically, there's another set of people who are using the AI for doing some stuffs, right? To making for making their lives easier, or let's say building some other softwares using available AI tools, and they don't have to know about the mathematics because they are just using what the builders have built. So now I'm talking about, guys, not them. I'm talking about the students, or let's say the developers who will be building this AI. So definitely you have to learn maths. So in your school also, please love mathematics seriously and try to understand these fundamental concepts, because the particular simple concepts that you will be learning in your school will be actually helping, right, to understand the deep mathematical concepts in your, right, future life when you, let's say, come to the university, right? And if you, let's say, select a subject like AI, then you will learn these stuffs. Hi. Right. I just want to give you kind of a bit of simple motivation for you guys about the mathematics. So anyway, I mentioned, guys, what we do is we are going to just build this intelligence inside the computer program using mathematical frameworks. All right. Right now, guys, I'm going to just bit deep. I'm going to dive a bit of the deep into this AI concept. So I mentioned in the AI programs, what we basically do is we're going to build kind of intelligence inside the computer programs to perform some kind of operation, right? So when we talk about, guys, AI, when we talk about the artificial intelligence based programs, we can basically identify there are 3 types of AI based programs. There are 3 types, dear students, right? First type is called as artificial narrow intelligence, right? Sometimes we call this particular thing as weak AI as well. Actually, this is called as artificial narrow intelligence. What is narrow means? It's very narrow, right? Very, I mean, that the space it has is very limited, very less. That is what it is basically talking about, right? Okay, I'll come to that point short while. Second thing is called as artificial general intelligence. General, right? Sometimes we call this general thing as strong AI as well. And we have another area called, guys, artificial super intelligence. Okay. What these 3 are? Very interesting, right? So, what is this artificial narrow intelligence, guys? Right. This is the thing, right? If a particular intelligence, right? If a particular intelligence can, that what the intelligence is doing is making some decisions, right? What the intelligence is doing is making some decisions. That is what the basic meaning or the purpose of an intelligence, right? So, that's kind of process. It's basically performing some kind of process and making some decision, right? Let's say a kind of intelligence which can process a single activity, right? A single activity only in a given moment, right? Let's say there's a kind of intelligence which can basically perform only one activity at a given moment. That is what is called as, guys, artificial narrow intelligence, right? So it can perform a single process, single activity, a single activity. That's it, right? For an example, let's think about, we have a kind of intelligence, let's say, to let's say identify something. For an example, think that we have a dog and a cat, right? So you want to identify who is the cat and who is the dog, likewise, right? Okay, just forget about the dog case. Now let's say we have a cat, so we want to identify whether it's a cat or not, something like that. So in that scenario, it's like a decision making. So we have to basically check the characteristics of the cat and identify whether it's a cat. It's kind of intelligence. All right. So if we can, let's say, do that particular thing only in a particular intelligence, or let's say there's kind of intelligence, it can basically identify cats or cats and dogs, let's say. Whenever let's say there's a kind of animal, it can basically identify, okay, this is a cat or dog, something like that's it. So that's a single decision making process, right? So if that particular intelligence is having the capability of making that intelligence, that particular decision only, that is called as what? Artificial narrow intelligence, or we sometimes call this thing as a weak AI, weak artificial intelligence. That is why, dear students, we call that thing as a weak, because it can perform a single task at a time. But just think about our brain. Just think about the human brain. In the human brain, just think about yourself now, right now. Let's say you are just listening to this particular lesson, right? But while you are actually listening to this particular lesson, sometimes you may be doing lots of other stuff, right? For an example, let's say someone may be eating, right? Someone may be eating something while you are watching this webinar. Some students, let's say, maybe just typing in, let's say, your mobile phone. So let's say chatting with some friends, or let's say some of the students maybe, let's say, listening to the webinar at the same time, let's say, maybe reading some kind of a note or something like that. Okay, so now tell me, guys, that means we can perform different tasks at a given time, right? Okay, we can perform, we can multiple, we can perform things multiple way, right? Okay, so for an example, let's say, while we are, let's say, doing something, for an example, just say that we are eating, sometimes, as a kind of a habit, most of us actually are just watching some movies, or let's say watching something while we are eating. Let's say in the home, sometimes we will be watching the news or some teledramas while you are watching. You are just going to think about what you are eating as well. At the same time, you're just watching at the whatever teledrama as well. So you understood everything in the teledrama. At the same time, you actually understand, right, about the taste, or let's say different, let's say, taste, or let's say whatever the let's say curries that you are having, everything is there. So that means, guys, our brain has the capability of making, right, basically decisions, or let's say processing stuffs multiple ways simultaneously, right? That capability is with us in our brain. This is what the AGI means, guys. So if you can actually build that particular multitask in nature, so in the narrow intelligence, we can perform a specific task only. But let's say if we can actually build the kind of a computer program which is like the human intelligence, like us, that is what is called as, guys, AGI, artificial general intelligence. Sometimes we just abbreviate it as AGI, right? All right, now I hope you can understand what is the ASI mean. So artificial super intelligence. Simply, guys, artificial super intelligence means the intelligence which is exceeding the human intelligence, right? The intelligence which is exceeding the human intelligence is called as artificial super intelligence. My dear loving students, do you believe, dear students, although we are talking about the AI at the world, right now, we have only, guys, this artificial narrow intelligence. That's it. We don't have this AGI or ASI at the moment in the world, my dear loving students, right? So we talk about the AI, but actually the AI that we are talking about at the moment is ANI, right? The particular AI frameworks or whatever the AI tools which are having, right, the capability of performing anything without having human intelligence, even ChatGPT, Midjourney, or self-driving cars, or whatever the thing, guys, they're just basically performing a single task at a time. That's it. So they can't perform the multiple tasks. So AGI, ASI, these are actually, we talk about these stuffs in the research field and in the companies, right, to actually improve these AI to this level. But unfortunately, so far, we couldn't actually achieve this AGI or ASI. That means all the AI programs or AI tools that we are having at the moment, they are actually under artificial narrow intelligence. I hope you understood what I was talking about. But anyway, guys, although we don't have this AGI and ASI at the moment, there are lots of researchers and lots of developments are going on, right, about finding this AGI, ASI in the AI programs. But at the moment, guys, there were no any AGI or ASI programs. All the programs that we're talking about actually are coming under this artificial narrow intelligence, right? So nowadays, I'll just discuss about those stuff later. Nowadays, actually, we are just talking about something called agentic AI. I'll come to that point later. I'll come to that point in a short while. Short while means at the end of this session, I am going to just discuss about that one. So basically, agentic AI means it's a kind of actually going towards this AGI. So what we are doing is, I mentioned that in a human intelligence, actually, we can do multi-processing. We can actually we can think about different stuffs at the same time. And while we are, let's say, while we are thinking like that, we can be talking and we can watch the things and understand. We can even, let's say, move our hands, and we can even actually lots of things can be done. So what happens is in the agentic AI, actually, it's talking about for each and every task, it creates a separate AI program, and finally it's combined, right? So we'll talk about those stuff later. We call them as an agentic AI. Okay, anyway, I'll come to that point in a short while, guys. Anyway, now I hope now you got my idea about this types of AI, right? All right. So it was basically mentioned in this slide. So I have already mentioned, guys, that NI means basically it can perform a specific task, right, in a particular AI program. And I have just mentioned some of the examples here, right? Google search and Apple Siri, Amazon Alexa, and Cortana by Microsoft, right? But nowadays that we don't use this one. And we have these image and facial recognition softwares, disease mapping and prediction rules, manufacturing drone robots, email spam filters, right? Social media some monitoring, some let's say bullying and dangerous like content, and entertainment and marketing content. That recommendation engines are very popular. YouTube, right? Netflix like platforms, self-driving cars. These are some of the examples. Even ChatGPT I have not mentioned here, but ChatGPT and all of the chatting softwares we are having at the moment in the world, they are coming under this artificial narrow intelligence, dear students. But I have already mentioned, guys, that AGI actually is as a theoretical concept. We talk about this, but at the moment, guys, it's not available in the world. But there are some organizations and some companies that are just doing some researching, right, about this AGI, right? And I mentioned about that agentic AI, right? So I'll come to that point later. But anyway, under the agentic AI, also actually our goal is to basically building some AGI based tools, right? But actually, guys, actually must understand they are also actually that the AGI is not happening, right? So still what happens that each and every task is performed by different agents and combine it together. So it's not like the human intelligence. Human intelligence means a single agent is doing lots of stuff. Let's say human intelligence means, guys, human is an agent. Just think about kind of agent, right? That agent can do lots of stuff, infinite, right, things. That is what actually the human intelligence means. I'll come to that later. Anyway, guys, there are some researches are going on, right? So there's kind of a AI framework called TOM, Theory of Mind framework. So if you have any kind of interest, you can just search about this. So this kind of mathematical frameworks, which is focusing about this AGI, right? So that is about, guys, basically AGI ideas to us. Right now, I mentioned about the ASI as well a short while ago. Guys, that since we can't access since we can't achieve the AGI level at the moment, guys, this super intelligence is actually not possible at the moment, dear students, because it's basically passing the human intelligence, right? It's more than human intelligence, dear students. So if you want to achieve this level, definitely we have to exceed that AGI level, right? So anyway, there are also here also actually some research things are going on, but most of these research is actually going about this AGI. But for the ASI also, right, some theoretical researches are going on. But although guys, this ASI, AGI, these stuffs are not actually, these are not actually available in the world. There are lots of movies and lots of let's say TV series and some videos, right, or some stories, some books you can identify, right, based on these ASI and AGI. Most of this actually under the ASI, we are talking about some intelligence which are exceeding the human intelligence, right? So that is what basically, guys, that the AGI and ASI means. So I hope you got my idea, right? All right, now, dear students, I mentioned we are going to talk about the ANI. Everything is talking about the ANI, right? Talking under the ANI. So under the ANI also, right? Basically, it is having the capability of performing a specific task at a given moment, but it's also again kind of a good intelligence, right? Ekat hona intelligence තමයි, because that if even a single task, let's say, if it can perform without the human support by making the decision by itself, it's a kind of a very big thing. Now we are going to learn about, guys, how can we build this intelligence inside these, right, inside these uh, programs, right? So before we move to that particular topic, guys, I'm going to introduce, right, the concept called agents. I mentioned, guys, now also actually we're talking about the agentic AI. It's a kind of a advanced area. It is what actually are now, in different seasons, there are different trends. In the tech field also, there are some different trends are coming, guys. At the moment, previously we had, I think a few years ago, we had the typical supervised learning based AI programs, and then we had these Gen AI, right? We talked about that one, generative based AI, and they are mainly focused about, guys, the image generation. We use some tools like GANs likewise, or generative adversarial networks likewise. So then actually there was a very hot topic, right? And that was the main topic, right? In the past few years, the large language models, basically with the intervention of this ChatGPT, right? ChatGPT, this large language models concept actually was it was a very huge hype, right? And now at the moment in the world, guys, we talk about this agentic AI, right? Okay, that's a different case. I mentioned, guys, in the agentic AI, what happens is we create a kind of a human-like, right? Human-like, uh, basically kind of a program which is working as an assistant to us, right? Basically, what what I can't do because of the laziness, or let's say because of the heavy workloads, I can just ask my agent to, or ask my assistant to do it, right? That assistant, normally we are having a physical assistant, but now we talk about AI assistant. That is what called agentic AI. Anyway, that's a different subject. We'll come to that point later. But now, guys, I discussed about the fundamental concept of the agent, because this concept actually is common for agentic AI as well as the typical AI programs. Whatever the AI program that we are going to build, guys, I mentioned, our objective is what? Our objective is to build an intelligence inside the computer program to make some decision by itself. And based on the decision it made, we want the computer program to perform something. That is what the main goal, right? That is what the main goal in the AI program, right? All right. Now, guys, although we have not actually directly talked about this, right? If I want the computer to make some decision on behalf of the developer, there should be kind of a artificial, let's say, artificial human. Just think like this way, kind of artificial human, right? Inside the computer program, itself, to make the decisions on behalf of the developer, or it's the user. Right? The user වෙනුවට program එක ඇතුලේ කවුරු හරි ඉන්න එපා. Right? කෙනෙක් කෘත්‍රිම මිනිසෙක් ඉන්නවා. Right? That particular human, that particular artificial human is the person actually who is making this decision. Right? Right? Okay, that particular entity, this is kind of very hypothetical entity, guys. එහෙම ඇත්තටම එකක් නැහැ. Right? අපි නිකන් හිතනවා. Right? We just think there should be some kind of, let's say, artificial human to make this decision on behalf of us, because then only guys, our requirement can be done. Understood? For an example, just think like this way. Now let's say today you have a class. Just think like this. Today you have a class, but let's say you are not well, then you can't go to the class. Right? Let's say you can't go to the class, and but let's say you need that, you want, let's say, to learn it. Unfortunately, because you are not well, you can't go to the class. Then what can you do? Right? If you want that to learn, right? Although you can't go there, but you can ask one of your friends, let's say, who is in the class, or some kind of a outside friend. You can ask, hey brother, please listen to the lecture on behalf of me and tell me what the teacher had told, or what the teacher has taught. Understood? Then you don't go there, but your agent is there, and the agent is doing the thing on behalf of you. Something like that. You know that in the computer program also, we are expecting kind of a hypothesis. There actually we had a actual person, actual agent was there, but here it's not like that, right? It's a kind of a hypothetical thing. But we believe there should be some kind of agent like that. Right? That is what is called as agent. But when we talk about the agents, guys, there are two types of agents, my dear students. The first type, actually, I have given that thing in the second, but I will discuss that one first. Physical agent. So actually, guys, the robots that you have been seen in the movies as well as in the real life also, we can see robots in the different companies. I hope that you will be learning about this robotic concept, I think, in the coming few weeks. Then you will understand these robotics things in detail there. Anyway, now you know who is a robot, right? So robots are in different natures. No, some robots are, they are like human, right? They are having kind of a face, they are having hands, right, legs, like. And some robots are there, they are like, let's say, they're cars, some vehicles, robot vehicles. They can just move here and there. Anyway, those are having kind of a physical structure, right? They are having kind of physical structure. Right? They are having a physical structure. So then this physical structure actually, right, is doing something on behalf of us. Ne? A physical structure and what they're current. For an example, let's say if you have a kind of a, let's say, kind of a robot, let's say, who is serving food to the customers in a particular restaurant. Then the restaurant me customers that just think that, let's say, in a particular restaurant, right? Let's say there's a robot who is serving the let's say, customers some meal, right? So in that scenario, right? So that robot is doing the thing on behalf of you, and there's a physical structure, right? That particular structure is a physical thing, right? Then guys, we call that thing as a physical agent, right? That is the physical structure who is doing something on behalf of us, right? And just think about kind of a robot car. So that is basically, let's say, following some kind of a road and doing something, let's say, avoiding the obstacles likewise. So basically, it is a kind of a physical agent who is doing something on behalf of the human intelligence. And not only that, guys, not only the physical things, just think about ChatGPT. In ChatGPT, we can't see any kind of a physical structure like that, right? Understood? In ChatGPT, we don't have something like that. In ChatGPT, we can see just a kind of a bar only. Only a single bar is there, right? So we have just typed something and we are getting some output. You can see, guys, in that scenario, we can't see a particular, right, a particular agent. But although we can't see a kind of agent there, although we can't see an agent there, actually, guys, there is a hypothetical agent, right? So we can't see the agent, but actually there should be that there is a kind of a hypothetical agent, but we can't see it because that is the agent actually who is doing that particular task for us, right? So when you just type something, the type something was understood and give the particular outcome in the, let's say, that output area, there should be some kind of agent. That agent is called as what? Software agent. Very important. So I have mentioned, guys, some of the examples. Let's say that Amazon, Apple Siri, Netflix recommendation systems. For example, let's say, I don't know whether you have watched the Netflix TV series. It has a very serious recommendation system. Let's say if you had watched kind of a movie or some kind of a video, something like that, you'll be getting the similar thing, right? In a short while, just after you have watched something, you will be getting a similar thing, similar, let's say, movies or let's say different stuffs in your right interface. And just think about the YouTube, guys. I think that almost everyone has used the YouTube now. When you just go to the YouTube and just search, let's say, kind of a let's say a kind of a song or something, then what happens? Guys, that a similar kind of a similar songs, or let's say the songs actually which were sung by the same singer, right, are getting recommended to you in the same environment, right? Who is doing that? There's nothing we can see, right? We can't see anything, but actually there is a hypothetical agent who is doing that thing for us. Understood? That is what is called as a software agent. That is what the software agent means. So anyway, guys, these agents are actually doing the things for us on behalf of us. All right. Now, guys, we'll discuss about, right, more about these agents, right? I mentioned the agents are doing what? Basically, agents are doing on behalf of the human, basically making some decisions and performing some operations without the human support. But I mentioned, guys, that all of these actually coming under what? Coming under narrow AI. It can perform a specific task at a given time, right? So in the world, guys, when we talk about the tasks actually that we are doing using the AI, we can identify them into two different, right, categories. One category is, guys, basically, right, that task, whatever the task is, a simple task. Basically, it is having a single outcome, single process. For an example, let's say classifying a kind of an email, let's say, to a kind of a good email or a spam email. Right? Just think about that. We normally call a good email as a ham. Let's say we want to just classify the email into the spam or a ham. Right? So in that scenario, right, it's a classification based on the image, based on the email content. We want to classify the particular email to whether it's a spam email or a good email. Right? That is a single activity, right? Those are called as simple activities, right? So if you have that kind of a simple activities, guys, then actually, guys, the particular AI systems which are basically handling these simple tasks using the agents, we call them as single agent systems. Single agent systems. For an example, let's say a chess playing program. So it's the agent is just playing the chess, that's it. And let's say a robot that navigates in a particular maze. And let's say a kind of a spam filtering, likewise, some kind of a single activity if you're doing. That is called as, guys, single agent systems, right? Some more examples I have mentioned here. Just think about just playing the games, in the robotics, right? And let's say in the medical diagnosis, let's say we want to just identify whether there's a disease or not, something like that. Financial forecast, likewise, in different cases that you can identify, guys, these single agent systems are working. But the thing is, guys, there are some cases the activities are very complicated. Very complex activities are there. For an example, guys, think about a kind of a traffic policeman. Think about the kind of a traffic policeman. You know, normally the traffic policemen are actually allocated in the places where we have, let's say, a kind of a four-way junctions, three-way junctions, likewise cases. No? There are, let's say, four roads, right, in four different directions. In the middle junction, the policeman is there, and that person is basically controlling the vehicles here and there, and right, he is actually helping to minimize the traffic. Guys, definitely you should have seen these stuff. In a particular moment, guys, the police officer has to use his full brain to process everything. Sometimes let's say, although we have some rules, or let's say we have some, let's say, ethics, or some whatever the things are there in the world, sometimes, guys, some people are just crossing the road here and there, right? For an example, now let's say a kind of a policeman has asked a particular vehicles in a particular road to come forward, signaled. But let's say suddenly a particular grandma is crossing the road in the same road where the vehicles are moving. But then can the policeman stay without doing anything? අයියෝ කමක් නැහැ. ඉතින් ඔන්න ඔය මම මගේ වැඩේ කරලා නැති හැප්පුණොත් කරන්න දෙයක් නැහැ. එහෙම ඉන්න පුළුවන්ද? Can the policeman stay without doing anything? Grandma is moving. Ayo, no worries, because I have done my work. Full responsibilities, grandmas, or whatever the vehicles. No, guys, policeman can't do it. Policeman has to, right, stop the vehicles and sometimes blame the grandma, likewise, blah blah blah. That's the thing, guys. In that scenario, guys, that definitely the brain is working here and there, right? Now the thing is, guys, I mentioned in the narrow AI, right? It can perform a specific task at a given time. So let's say I want to build a kind of AI system to replace this policeman in a particular traffic, that particular junction. Can we use a single agent for doing that, dear students? What do you think? Single agent can, because single agent can perform a specific task only at a given time. It's actually very complicated, impossible thing, dear students. Because why? There you have to sometimes make the decisions based on different characteristics. Just think about that. It's, let's say, raining. So if it is raining, guys, that you have to think about that as well. Let's say that the particular road is, let's say, having water, right? And it's very, actually, there are lots of cases that you have to consider, guys. Sometimes we can't see the vehicles very clearly because of the rain, right? Like that. So that's a complicated case. Those kind of situations, guys, we have to handle. We can't just handle with the single agents. We have to go with, guys, multi-agent systems. We have to go with the multi-agent, right? So in that scenario, what happens is, guys, basically, rather than we are using a single agent to do something, we use different agents for actually different areas to make single decisions by each of them, And finally, they should be getting combined and make a final decision. Understood, guys? That is the thing, right? They're just separately just working and basically uh, making the decisions separately, and finally they are going combined, and final decision is made. So those are called as, guys, multi-agent systems, right? So I have just given some examples. Let's say one of the very right uh, suitable example is, guys, traffic controlling, right? Not only that, guys, in supply chain management, let's say there are different ways of supplying some, let's say, products. That scenario that we have to think about different cases, and then sensor networks, right? Social simulation, likewise, different examples we can identify, right? Basically, when we are dealing with this multi-agent system. Okay, whatever the agent, single agent or a multi-agent, guys, what happens is we are just, instead of us, we are going to build some kind of a agent who will do the things on behalf of us, on behalf of us. Now, this is the thing, guys. If the agent wants to make a decision on behalf of us, whether it's a single agent or multiple agents, it should be having, what? A kind of intelligence. To have the intelligence, guys, definitely the particular agent should be having a brain. Having a brain, guys. How can we build this brain? Because in the human, the brain is the part in the human body which is helping to, right, make this intelligence. Understood? Which is helping to basically keep this intelligence, and which is helping to make these decisions, right? So what happens, guys? If I want to, let's say, right, work with these agents to perform something, definitely, guys, we have to build a kind of a synthetic brain inside this agent. How can we build this brain? Because if we have built this brain, then only, guys, then only this agent can perform some kind of a task by itself and give the result on behalf of us, right? How to build this? That is where, guys, we need mathematics. I mentioned, right? I mentioned already. All of these actually coming under, guys, mathematical concepts. So I have mentioned here some of the mathematical concepts, my dear students. You guys can see, right? I have not mentioned here everything, but these are some of the mathematical concepts, mathematical frameworks which are available for building this intelligence inside the brain of the agent, right? But we don't discuss about these stuffs in this particular discussion, right? We don't discuss about these stuff. I'll just focus about only two things here, right? Only two stuffs here. The first thing is, guys, expert systems. Second thing is machine learning, right? So these two are the topics I'm going to focus in this particular discussion. All right? Okay. All right. So can you guys please type yes in chat box if you understood so far? Can you please type yes in chat box if you understood so far? Okay. I hope you got my idea, right? So this is what, right? This is what basically, right? We are going to discuss here today. So I'm going to first start my discussion, right? Start my discussion about. I'm going to start my discussion about the expert systems first of all, and then I'll come to the machine learning concept. All right. Okay, so give me 1 minute, and I'll come back to this one. All right. So, right now, sorry guys that I had actually kind of urgent thing. So, right now I mentioned guys that here, right here, this is how actually we can make this intelligence inside kind of a agent, right? So I'm going to discuss with you about basically these two, right? Expert systems and the machine learning, this concept. So under that, first we'll discuss about guys, expert system. Okay. First of all, you must understand one thing, right? First of all, you must understand one thing, guys. So in the basically AI program, so we are going to actually build kind of an intelligence, no? Right? We are going to build an intelligence. You know, it is something like, guys, that the parents are basically building the intelligence of the babies. Understood, guys? You know, when a baby comes to the world, right? Baby doesn't know anything, no? Understood? Baby doesn't know anything, right? Baby just knows to cry. That's it. Right? Baby doesn't know anything, guys. There's no baby which is coming with an intelligence, right? He knows just to cry. That's it. So whether whether you actually believe or not, guys, guys, the 100% credit or 100% basically 100% basically the respect, right, actually is going to whom? Actually, our parents as well as, right, whoever actually built you, right, built you to this level, right. One in our life, right, in the baby life, actually the parents have, right, built us to some level, and then, right, with their guidance we are getting the supports of the teachers as well, right, school teachers, now actually you are in this level. So teachers, and then when you come to the university lecturers, and likewise lots of people, even society, right, every person, everyone actually is a part of your intelligence building, guys. Your intelligence is built based on this. So that is how, guys, that unknown, that particular baby, without having any knowledge, any intelligence, or without knowing anything, becomes a kind of a, right, becomes a kind of a person who is, let's say, a kind of very intelligent one in the world, right? Otherwise, how it comes? It is not coming. It is not coming basically automatically, right? All right. Okay. That's the thing, guys. So just, guys, that just think about this one now. Let's think about this one. Very simple example. Let's think about the kind of musician, right? Musician. Guys, definitely, that we are actually living in the scientific world. In the scientific world, in the biology, we believe, right, our all the skills and our all the capabilities are actually coming to our, right, our life based on our genes, right? Because in our gene, right, we have, right, some different basically structures which are helping us to become to this level. But just think like this: now let's say there's kind of a person, a kind of baby, where the genes are having, right, uh, let's say the needful let's say the needful elements uh, for being a musician. But let's say that baby is not learning music. Let's say that the baby is not going to any music class, or let's say not using any kind of let's say instrument, or let's say not actually having any idea about the songs or anything. Now, can that person be a musician? No, right? Although the genes are supporting to his goal, without having a proper, let's say, building, or let's say proper guidance, that person cannot. For an example, let's think about a kind of a person, let's say, who is having the genes, which are supporting to, let's say, being a cricketer, right? Cricketer, genes are there for supporting to being a cricketer, but let's say if that person is not actually learning cricket, or let's say not playing cricket at all, then how can that person be a cricketer? No, right? Definitely, guys, definitely it should be built. Should be built. That is why the teachers are there. That is why the parents, or let's say the guiders or the trainers are there. Right. That's the thing. The same thing happens here as well, guys. Same thing happens here as well. So basically, right, we have to think, guys, these mathematical frameworks actually they are like, let's say, some ways of teaching, or let's say some ways of guiding the agent to do some kind of a thing, or let's say making some decision. All right, let's come with the expert system, the most basic way of building the intelligence inside a computer program, inside an artificial intelligence program, right? So basically, it's something like this. In your younger time, when you were very small buddies, very small kids, now sometimes you can understand, right? Okay, why your parents have asked like that. But sometimes in your child time, sometimes you may not, sometimes you may have not thought, okay, why the parents have mentioned. For an example, let's say sometimes, let's say in the Montessori time, or let's say in the grade 1, likewise, sometimes the parents are asking us, right, not to go with anyone else other than mom or dad, or let's say whatever the uncle or auntie or whatever the your family kind of a member. Parents are asking, Puta, don't go with anyone, right? Whoever asks you to come with him or her, right? If he or she is not the dad or mom or whatever the family member, like that. So normally it's a kind of a common thing, right? Right. In our time also, my dad, my mom also had, right, asked me like that. Don't go with anyone. If someone asks you to come, don't go. Then what happens? Then normally, whether normally, uh, do the parents tell babies why? Normally, බබාලට කියනවද අම්මා තාත්තා මෙහෙමයි මේක තමයි හේතුව ඔයාට මෙහෙම කරනවා මෙහෙම කරයි කියන්නේ නැහනේ. Right? The parents are not telling like that, right? Parents are not telling the reason. Parents are just telling, don't go somewhere. Don't go with anyone, right? Except for mom or dad or family member, something like that, right? අම්මා හරි තාත්තා හරි නැතුව යන්න එපා කොහෙවත්. right? කවුරු කතා කරත් යන්න එපා. ඉස්කෝලේට ඉතින් කියනවනේ ඉස්කෝලේ යනවාම යන්න එපා. අපි නිකන් ඉන්න කියලා likewise. So එමෙ කියනවනේ. So then in that scenario, guys, the baby doesn't know, right? Why? But what happens? Baby had been informed to do something. Understood? So basically, we can just identify them as rules. Understood? Some rules, right? Parents are rules දාලා දෙනවා බලන්න. මෙහෙම කරන්න කියලා. සමහරට හේතුව කියන්නේ නැහැ. They don't tell the reason, but they had basically imposed some rules. Sometimes, let's say, sometimes you may have seen, guys, in some places, right? Sometimes you can see, even in the road, let's say when you are driving, or let's say when you are, right, going in the public roads, guys, that there are some rules given. Don't go to this direction, right? Sometimes some people there, don't stay here, please go. For an example, in the highway, that it has mentioned, okay, this is the let's say speed limit you can go, you can't go beyond. These are what rules, guys, right? There's nothing to understand. Understood? These are rules. Rules විතරයි තියෙනවා. ඒක තේරුම් ගන්න දෙයක් නෑ. Rule එකක් තියෙනවා, right? So then what we have to do is that we have to follow the rules and go do something. Something like that, guys. Something like that. Actually, when the AI programs were built in the world for the first time, right? Actually, this is what, right? This is what, guys, they had in the programs, the expert systems, they basically, right, they basically focused about the rules. Based on the rules, the programs were basically instructed to do something. You know, guys, that if you are familiar with the programming, I think at the first session also I did with you the Python. Just think about the if-else programs, right? If-else programs. So we learned about the if-else now. There, what happens? If this happens, do this. Otherwise, do this. Likewise. Even we can write multiple conditions as well. If this happens, do this. Else if do this. Else if do this. Else if likewise. We can just give some different, right? Criterias. And in each criteria, we can just ask the program to do something. Right? You know, in that scenario, guys, that we don't tell why this should be followed. What is the reason behind? So it does not focus there, right? Just follow this rule and do this. That's it. May rule follow something like that, right? Those are called as what? Rule-based systems or expert systems, guys. Expert systems. Understood, guys? This is the thing. But the thing is, guys, you know that when actually these rule-based systems were used, actually these were used, guys, for a long time in the history, in the IT history, in the AI history, guys. Actually, this is how the AI programs were built previously, right? So basically, they were built, right, based on that, and based on these basically rules, guys, the things were basically performed by the AI programs. I hope you got my idea, right? So, but the thing is, guys, you know that when we talk about, so actually we are going to actually, guys, build kind of a human intelligence inside the computer program, right? We are going to build kind of an human intelligence inside the computer program. You know, guys, that when we talk about the human decision making, right? When we talk about the human decision making, guys, actually, you know, human decision making is not actually much static. Understood? It's not a static thing. For an example, let's say let's think about kind of a person who tells, okay, uh, let's say if I ask from that one, let's say, what do you like to eat tonight? Someone may tell, okay, I'm going to eat a kottu, cheese kottu today, right? But sometimes suddenly, guys, sometimes let's say if someone, let's say, is going with a burger somewhere, if that person, let's say, sees that burger, sometimes he may tell, I think I will move to the burgers. Likewise. Understood? That's the thing, guys. So always the human decisions are, we call that thing as basically they are ambiguous. They are not actually, they are not static. They're just changing, as well as they are having different variations. For an example, just think about this way. Now let's say there is a person who is having the height of 180 centimeters. Let's say the height is 180 centimeters. And let's say there is another person who is having the height, let's say 150 centimeters. One person is there 180 centimeters, another one is 150 centimeters. Let's say 150 centimeter, that person is, let's say, meeting that 180 centimeter person. Then let's say if the 150 centimeter person comes in front of the 180 centimeter person, according to the 150 centimeter person, guys, that 180 centimeter person is what? He is a very tall person. Am I correct? Right? දැන් අර සෙන්ටිමීටර් 150ක් උස මනුස්සයා ගියොත් එම් සෙන්ටිමීටර් 180ක් උස මනුස්සයා ඉස්සරහට එයා කියන්නේ මෙයා උස මනුස්සයෙක් කියලා. Understood? According to that particular 150 centimeter guy, that he's telling, okay, this is a tall person. But let's say the same 180 person, let's say is met by a person who is 200 centimeters. ඉතින් සෙන්ටිමීටර් 200ක් උස මනුස්සයෙක් හම්බෙනවා අර 180 centimeters මනුස්සයාට. Then according to the 200 centimeter person, guys, definitely he sees that particular 180 centimeter person as what? As a short person. The 180 centimeter manusyava desiyekකට penne kota manusyak විදියට. Got my point. That means you can see, guys, that these decisions are basically changing. Understood my point? Then, guys, the decisions cannot be static. In the rule-based systems also, this is a kind of a problem, guys, because that we can't always make the rules, okay, if this happens, do this, because why? Because the decisions are basically, they are basically ambiguous. That is why, guys, that later to these particular expert systems, there was a very nice concept introduced called fuzzy algorithm, fuzzy logic, FUZZY, right? That particular technique was introduced, fuzzy mechanism was introduced, and it actually gave these expert systems kind of actually basically a way of making the uncertainty in these decision making process. But the thing was, guys, again, guys, that is also not much effective, right? Because the thing is, one of the very serious thing in this rule based system is everything is hard coded. Everything is hard coded, guys. Come on, hard code. So basically, if this happens, do this. If that happens, do this. If this happens, like for an example, let's think about kind of a complicated area, guys. If you want to build an intelligence based on that particular uh, scenario, you have to, guys, write all the possible cases as your rules. වෙන්න පුළුවන් ඔක්කොම ටික අපිට rules කරලා ලියන්න වෙනවනේ. So if you, let's say, make everything as rules, guys, your program is getting very, very, very big. It's complicated. So if it is complicated means, guys, one thing is program is getting much more slower. It's getting slower. That is one thing. Another thing is, guys, sometimes the program may not be processing correctly because of the computational limitation. Right? That's another thing. So because of that reason, guys, these particular rule-based systems actually were not used for performing bigger tasks. Very small, very deterministic, let's say, specific static cases were, right? Static cases were solved by these expert systems. Let's say there's a kind of a scenario, let's say let's say, case where you have specific conditions. In each specific condition, let's say you have, okay, these should be done likewise, and that scenario you can use this expert systems. But guys, it was not much practical. That is why, guys, the mathematicians were trying to find another mechanism to replace these rule-based systems to make more accurate and more realistic decision-making things. Then, guys, they realized something like this. In our baby time, right, our parents have asked us to do something based on some rules, and we have followed them. But, guys, when you were growing, right, guys, right, when you were, let's say, getting older and older, what happened to your decision-making process, right? You don't know, sometimes this was happened, but actually, guys, with the teachers and with the parents and with the society, actually, guys, your decision making process was converted to a different level where, guys, you are making the decisions not based on the rules but based on the past experiences, right? හොඳට හිතලා කියන්න එහෙම නෙමෙයිද කියලා. Your decision making process was converted to, it was basically happened based on your past experiences, wasn't it? Can you please type yes in chat box? එහෙමද නැද්ද කියලා? Can you please type yes or no in chat box? Were your decision making happened based on your past experiences or not? When you were growing, when you were getting older? You can just type in chat box and you can even give your thoughts. Can you please just give your thoughts in your chat box? I was asking guys that your decision-making process, right? It was right in your baby time. Actually, it was basically a rule-based thing. Basically, your parents have asked you to do something, you had done it. But when you were, let's say, when you were just right growing, when you were getting older, right, the decision-making process basically was converted to a different level where the decision-making is happening based on your past experiences. That's the thing, right? That is a very nice thing, guys. Ah, that means guys, based on things that you have been experiencing, you actually make the decisions. For an example, let's think about guys. Uh, let's say let's think about okay, how can I say? Just think about in your grade 5 in Sri Lanka, right? In Sri Lanka, you know that in the grade 5 we have the scholarship exam. So in the exam, some of you guys may have faced for that one. So you know, guys, that we have to do that, and then we have to select some school, right? So when actually you are selecting the school, guys, you are normally selecting the schools as you think which is the best, right? Based on your result as well. So when you're selecting the school, guys, what you're thinking about, guys, you're thinking about, okay, the things that you have heard about the school, and let's say the educational quality, or let's say what sometimes the distance from your home, likewise different things that you think. So those are actually based on your things that you have been experiencing so far. But let's say when you let's say come to, let's say, to the O level, sometimes that some of the students may be there actually from the O level, some students who are doing the A levels. You know, guys, that when you actually finishing your O levels, then when you are actually selecting a kind of a subject to your advanced level, let's say combine mathematics or biology, or let's say whatever the commerce stream or whatever the subject area, guys, that again, guys, it was decided, most of the students, if I ask from you guys, you have decided based on your, sometimes your parents request, sometimes let's say your friends had done it, sometimes you, one of your, let's say, family member, someone had done whatever the subject area, and sometimes let's say you may have seen some of job opportunities based on that particular subject area. Like, that is the thing. So again, based on your previous experiences, and when it comes to, let's say, after the let's say A levels, guys, that when you come to the university level, you have to select a university as well as a degree program. So again, guys, you are going to select your degree program based on the knowledge and the experience that you are having at the moment when you are selecting that particular stream, right? And when you go in different levels in your life, guys, again, what happens? Up to that point, what you have learned, or let's say what you have basically experienced in your life, you use for making the decision. That is the thing. That thing was actually realized. That thing was basically understood by the AI developers, or let's say AI, right? Uh, the scientists. And guys, they identified a very beautiful area called machine learning. Machine learning. So basically, machine learning means, right? Machine learning means, guys, making the decisions based on the experiences. That's the thing. Making the decisions based on the experiences. All right, now I ask from you, what are the experiences means? What is your experience means? You know what experiences means, guys? The things that you have seen from your eyes, as well as the things that you have heard from your ears, the things that you have tasted with your, let's say, tongue, or let's say your mouth, right? The things that you have touched, let's say, from your, let's say, hands. Likewise, the things that you have felt with your body, your skin, the inputs. Got my point? The inputs, basically. From the eyes, you get the visual inputs. From the, let's say, from the from the tongue, or let's say from the mouth, you got the taste inputs, right? Different elements of the taste. And from the ears, you got, let's say, the audio inputs, right? And let's say from the skin, you get, let's say, different things which are actually, right, felt by the skin, like, let's say, temperature, right, cold, likewise, right? Inputs, very important, guys. In other words, what? Data. That's the thing. So actually what we are getting is data. These are data, guys. What you feel to your hand is a data. The particular feeling is a data, right? The thing that you get into your eyes, right, from the outside as a vision-based elements, they are data, images, videos, likewise. Things that you hear from your ears, they are data. Understood? Everything is data, guys. That's the thing, guys. So what we do here is, guys, like actually we have got the things to our right, our body components, and from these actually we actually got some experience, and with this experience actually we are just making the decisions now. The same thing we try to do in the AI programs. We just, so now the thing is, guys, this, as a human being, actually we know what we are doing. Actually we are the people actually who are experienced by ourselves. But the thing is, guys, in the AI program, it doesn't have any kind of a live to do that thing by itself, right? So we have to do it. We have to do it to them. So, for an example, in our human body, guys, that the things are getting to the eyes, right? We can just go and watch it by ourselves. But the AI programs cannot do that, no. Then we have to show them. Understood? We have to show the AI program. We have to show to the AI program, okay, these are the images, these are the things, these are the data, likewise. Let's say these are the audio, then we have to put the AI, we have to put the audio files to the AI program. And we're also, okay, these are the audio things, these are the video things, these are the images, these are the data, likewise. That's the thing, guys. In other words, what we are doing, we are going to teach the computers. Very nice. We are going to teach the computers to learn from the data. And then what happens? And then, guys, we ask the computer to make the decisions based on the understanding it got from the data. That's the thing. That is what basically we do in the machine learning. I hope you got my idea, right? That is what basically we're doing in this machine learning, guys, right? So now, guys, how to teach the computers? That's again a problem. How these computers are learning from us, learning from the data, how it happens, again a problem. Then that is what we are going to discuss now, right? So basically, guys, there are three ways we can identify under this learning. Actually, guys, this is again how we learned in our school or in our Montessori, in our baby time. මේකත් අර අපි ඉගෙන ගත්ත විදිහම තමයි. Right? It's again the way that actually we have learned in the school or a Montessori or whatever the university or something. Right? So basically, we have three ways. I'm going to explain one by one, guys. So we are going to mainly focus about the first one, but other two also I just briefly explain, guys. The first one is supervised learning. Supervised learning. What is a supervised learning means? You know, guys, this is the most common way of learning. In our day-to-day life, guys, most of the things were learned by this supervised learning, guys. අපි අපේ ජීවිතේ වැඩිම වාර ගානක් ඉගෙන තියෙන supervised learning වලින්. In the school as well as in our life, in our day-to-day life, from our mothers and fathers and our let's say our family relations and our friends and our society, guys, most of the things that you have learned based on supervised learning, right? I will do a small activity with you. One podi activity right? I'm going to basically do a small activity with you, but guys, I need your full basically response or interaction to this particular activity. මම දැන් ඔයාලට එක පොඩි activity එකක් කරන්න යන්නේ. හැබැයි මට මේකට ඔයාලගේ support එක උපරිමයෙන් ඕනේ. I want your support as well as you have to give your responses. Otherwise, this particular activity is useless. Understood? So then you have to respond me. So please use your chat box and quickly respond, guys, when I ask this question. So I'm going to show you something. Right? So I'm going to show you something, and then you have to give me the answer based on what I'm going to show you. Right? So I'm going to basically check your brain power. Now you will understand, guys, how you learned in your life now. Right, guys? Let's start with the first. Right? So I have here shown a kind of a color. Now I have shown a kind of another object, which is a ball. Right? And I have asked you to guess the fruit. Please guess, guys. Quickly. You can just type in chat box. So I have shown a kind of a color, and I have shown another kind of object, and I have asked something called guess the fruit. So you have to guess a fruit. What is that? Can you please quickly type in the chat box, guys? It doesn't mind. It's totally fine, guys. That write the wrong answer. That's totally fine. There's no problem, right? But I need some response from you. Okay. So please guess. Okay. That was one answer. I need more answers. I think we have around, yeah, I think we have around, right, 5 students at the moment. You can just cue me some answer, right? Totally fine. What do you think? All right, fine. I think I got the answer, which is, again, I'm also agree with that. Can you please just type yes in chat box if it came to your mind that orange? Please type yes in chat box if you got into your mind the orange fruit. Orange එක කියන එක ඔලුවට ආවද type in yes කියලා. I think that one of you guys had given the correct answer. Others, please. All right. I hope most of you guys may have thought like that way. Actually, myself also right, suggested orange. Yes, that's the thing. Why that happened? And the most important point is why? Why the orange came to your mind? You know, here I have not shown any orange, right? I have shown kind of a ball as well as a kind of a color. Why? Because, guys, you must understand, this is how, guys, our brain has, right? Brain has identified the things, learned about the things. We have basically, guys, identified the characteristics of the object. Right? අපිට මොන හරි item එකක් ආවම item එකේ characteristic තමයි බලන්නේ අපි. තනි item එකක් විතර පොළු තියාගෙන ඉන්නේ නැහැ, guys. We normally separate the things and we get the characteristics. That is why, guys, you actually got your mind, right, this is like orange here. Understood? Because the thing is, the color is there and the shape is there. Another example. Right. Now, can you please guess the fruit here? So here we have a kind of a, again, a color, and there's another kind of a, right, table is there. And you can just think about different stuffs here and just guess the fruit. What is the fruit, guys? You can just type anything. That's totally fine. There's no problem of actually making the mistakes, because that is totally fine, right? You can type anything. The thing I need is actually the responses. Anyone, please? All right. Can you please type yes in chat box if you go to your mind mango? I got like that way. What about you guys? Can you please type yes in chat box if you got mango to your head, your mind, when you were looking at this particular picture? Right? Again, the same thing. As you can see that here, this table actually is like a, right? It is having the shape of the mango, right? And the color is also like a very nice, right? Very, very tasty, right? Mango, right? What about this, right? So here we have a kind of a color, right? Can you please guess what is this fruit? So here we have the color. It's actually like red and pink likewise color. All right. So yes, we can just guess like, let's say strawberry, likewise. So and what about now? If you have given like this kind of a thing as well, it's like apple, because the apple actually that tail area is like this way, right? Another one. Just think about this one. I will say here we have a kind of apple is there, and then something called United States and 3.606 million trillion used something like that. What is this? Definitely, guys. What comes to my mind is the iPhone, or let's say a kind of Apple device, something like that. So the thing is this, guys. This is how actually you learn from the characteristics of the date of the right elements. So then you have identified things based on the characteristics. We call them as features. So based on the features, guys, you have identified, right, okay, this should be this, that should be that, likewise. Understood? So I hope now you understood what I just explained. Same thing actually is, right, done in our school time as well. What happened was the teachers actually showed the things with the example. Just think about, guys, kind of a mathematics lesson. Let's say just solving kind of equation likewise. So in that scenario, lots of examples were done by the teacher, And then the teacher actually explained examples, and then based on that, we actually understood, all right, what's happening. So basically, we try to identify kind of a relationship between the inputs and the outputs. Understood, guys? That is what basically the supervised learning means. So the same thing, guys, is happening, right, in the AI as well. You know that here we have, let's say, a kind of a cat image, and then let's say we have a kind of a label called cat. So we teach the model, right? Okay, if you have this kind of input, this is a cat. So we have to tell the model, guys. So we are the people actually who are giving, right? Okay, this is a cat image and this is a cat. Another example. This is a dog image and this is a dog. Likewise. This is again a dog image, this is a dog. Likewise. Understood? And let's say this is another cat and this is a cat. Likewise. So we have to show the model the inputs and outputs. Inputs, outputs. So what happens, guys? The model will actually, so inside this black box, guys, this particular black box is the area where the algorithm, there are some algorithms, guys, under the machine learning, which are having the capability of extracting the characteristics of the inputs and the outputs, right? එයාට හැකියාව තියෙනවා inputs වල outputs වල relationship එක හදාගන්න. Those algorithms, right? So they call them as supervised machine learning algorithms. So there are different supervised machine learning algorithms, guys. So those algorithms are having the capability of actually extracting the features of the data. මේ data වලින් යට අවශ්‍ය කරන features ගන්න පුළුවන්. Data can be extracted. And then, guys, based on that, these algorithms, we call them as trained. Train වෙනවා කියලා. They are getting trained, and based on that, guys, they can basically, right, perform what? Right, whenever, let's say, if they have been trained with the relationships it got from these inputs and the outputs, it will basically give the predictions correctly, right? I hope you got my idea, right? That is what basically, right, happening in a particular machine learning model. But the thing is, guys, you know that that we are actually making our decisions in our life, right? We are making the decision in our life, in our right, in our life scenarios, guys, based on our previous experiences, right? Sometimes we even, guys, make some wrong decisions in our life, right? අපි ජීවිතේ වැරදි decision සමහර ගන්න අවස්ථාවක් තියෙනවානේ. Sometimes, let's say you have let's say decided to go with some kind of a, let's say, knowledge area in your life. Let's say you have decided to go with, let's say, sports, right? So I'm going to go with sports, something like that. But sometimes your passion, or let's say your skills may be, let's say, towards music. It may be. Sometimes, let's say you have decided to go with sometimes, say, civil engineering, but let's say your passion is, let's say, maybe with the computer science. Likewise. So like that, guys, sometimes that our right decisions may be wrong, right? Somehow we make decisions why? Because we make the decisions based on our previous experiences. Likewise, guys, in this trained models are also sometimes giving wrong predictions, sometimes based on the data, data on which, right, it was trained, right? A model like a train which data anuva සමහරට වැරදි decisions ගන්න පුළුවන්. For an example, let's say this particular this particular model, actually I just talked about training cats and dog images. Now let's say this particular model was trained on very big dogs and small cats. Likewise, ඉතින් ලොකු පූසොන් වයි ලොකු බල්ලොන් වයි පොඩි පූසොන් වයි දාලා model එක train කරා. Think like that, right? If it was like that, guys, එහෙමනම් කරලා තියෙන්නේ, then what happens? Then, guys, definitely when you are getting kind of image of a very big guy, definitely it will be predicted as a dog, because then a characteristics are taken. The image size or height is also what? The relative height is also kind of a characteristic, like that. Now what happens for this image, guys? then make and walk with. This is like a small puppy. You know, definitely, guys, right? There's a very high chance of actually making this particular prediction as a cat. And this is a wrong prediction. Understood? Make a wrong prediction. Make a prediction. Got my point, right? Another example, let's say that here we have a tiger, right? But you know, the shape is like a cat. So definitely, guys, this will be sometimes predicted as cat. So it's again a wrong prediction. I hope you got my idea, right? And this is the thing actually we may be actually facing when we actually dealing with supervised learning. That is what actually, guys, as the AI engineers, we are hoping to do. That is what we are going to do. Actually, we are just expecting to basically to actually minimize this error. Understood? That is the plan. We are just minimizing this error. We want to minimize this error, guys. We want to minimize this error, and we want to get a more, let's say, accurate predictions from the model. Got my point, right? That is what we are just hoping to do. We want to get more accurate results from the model. That is what the duty of the AI engineer, guys, AI researcher. So we try to develop. How can we make the accuracy? Oh, it can be done based on the data, basically. Data can be, let's say, taken with very high variation, because the particular variation that you show to the model is the reason behind the quality of the learning, guys. Because let's say if you have shown the model different types of data, different variations of the data, guys, then the model has gone through these various types of data, and it has identified the variation of this data, and based on that it will give you basically the prediction correctly. That's the thing. Got my point? But let's say if you have shown a very limited variation in the data, let's say all of these dogs are, let's say, like very similar, let's say the same color, let's say black color dogs, same height, big, likewise. Let's say the cats are very small bodies, likewise. Then, guys, definitely your predictions may be getting wrong if you are getting some kind of a different kind of a one is, let's say, given to the model to the prediction. Definitely the results may be wrong. That's the thing, right? Okay, understood? That's the kind of a thing that you have to understand. So that is what, guys, the supervised learning means. I hope you got my idea, right? So I hope you understood, right, what the supervised learning means. So kind of way of actually teaching the model to actually make the predictions in the AI, right? All right, prediction means making a decision, basically, right? Now let's come to the second type of the machine learning models, guys, unsupervised learning, right? So, you know, in the supervised learning, guys, actually we showed the model both X and Y, right? We showed the model both X and Y. So based on this X and Y, so it identified a relationship, and based on that, actually, we can basically, the model can actually understand it, and it can make a prediction based on that. So as I have already mentioned, to identify that particular, basically that particular relationship, right? We have different right algorithms. Algorithms are there, right? There are different algorithms we can see. So these algorithms are basically, right, getting the relationship from these inputs and outputs. But just think about this in your life, guys. There are some cases in our teachers, you may have noticed, guys, they have not actually shown the examples. Instead of that, they have actually gave us the challenges to do the things by ourselves and learn. For an example, let's say in your school time, right? or let's say in your Montessori time, if you have, right, experienced it, sometimes the teachers are giving babies the clays, or let's say clay, or let's say building boxes, and ask them to build something. For an example, let's say they may be asked to build, let's say, a kind of a house from the building boxes. And then what happens, guys? Then the babies are actually, they don't know how to do it, but they just try, right? Or different ways, just try to identify some kind of relationship between these, right, these building boxes. And they try to find and create something like that I have mentioned in this particular, right, this particular small GIF. You can see that there's a small baby. She is actually creating kind of a, right, structure with these building boxes. That's the thing, guys, right? So basically, guys, that here we have that the teacher has not shown the output. Instead of that, guys, the teacher had actually given just the input. That's it. Like that, guys, in the machine learning also, we have an area called unsupervised learning. We call it as unsupervised learning. We don't supervise it. So there what happens is we show the model just the input data. That's it. We don't show the output. We don't show the output. We just show the input. That's it. We show the input and then we ask the model to, right, identify some hidden basically, let's say, the characteristics, or let's say hidden relationships, hidden clusters, groups, likewise, through this data. That's it. Simple, right? So I have here, right, I'm going to explain you this concept with very simple demonstration, guys. Very simple activity. You can see that here I have given some, right, actors and actresses, right, in this particular slide. And some of these actors and actresses you may know, right? And let's say I want to group these data, let's say, into two different groups. But now, previously, guys, I guided the model, right? I guided the model how to do it. But now I don't guide. Now I don't guide, guys. I just actually, I just give the data to the model itself and ask the model to do it. That's the thing. I just ask the model to do this. I'm not going to guide it, right? Now what happens, guys? If the model is doing that, let's say I need only two groups among this data. If I want two groups, right, in this data, right, there are different ways, guys. I can actually create two groups among this data, right? Right. So right, this is one way. That here, right, in this side you can see the characters or actors and actresses in Harry Potter movie. You can see. And in this side, guys, we can see, right, other people. And this is one of the way actually we can group this data. Another example, let's say here we have Twilight movie series, the characters, actors and actresses. And here we can see others, right? And here we can see, right, gender, gender base, right? Here we have females and here we have males. Understood, guys? Right? And what about here? You can see here we have, right, genre, right, the comedy and the non-comedy likewise. So these are possible ways actually, guys, we can have in these groups. We have asked the model to group this data into two groups, but we have not mentioned how. So it will basically group this data based on its understanding or the relationship it had got from this data. And that is what here we can see. Very simple. Got my point, right? So this is what happening in the unsupervised learning, guys. In the unsupervised learning, this is happening. So there are different algorithms which are actually having the capability of basically grouping or clustering these data. There are different clustering techniques. So as well as some more other different techniques as well. So only thing is, guys, that we don't guide the models how to do it. Models will guide karanna. Models will be doing the things by themselves. Model එක විසින්ම තමයි ඒක කරලා, right? ඒක අපිට output එක දෙන්නේ. I hope you got my idea, right? Now let's say if I have let's say asked the model to group this data into 3 groups. Now you can see the language can be taken as the criteria here. Let's say Sinhala language, Hindi, and English likewise. So the data have been now grouped like this. So I hope now you got my idea. This is how, guys, we can basically do the grouping, right? And here, guys, we have not supervised. The model has gone through the data, identify the relationship. How to identify the relationships? It is happening inside the algorithms, guys. There are some clustering algorithms, right? So some association rule discovery algorithms. The clustering algorithms I can just mention as there's a clustering technique called k-means clustering, hierarchical clustering, and density-based clustering. And then under the rule mining techniques, we have the priori algorithm, and under the eclat algorithm, likewise, there are these different machine learning algorithms. I forgot to mention, guys, under the supervised learning, also we are having some algorithms like linear regression, logistic regression, k-nearest neighbors, support vector machines, bagging, boosting, random forest, decision trees, and regression trees. Lots of techniques are there. Understood, guys? There are plenty of machine learning techniques we can identify. So we can basically use them for our learning purposes. All right. So that is what, guys, basically, right? Unsupervised learning means. Now let's quickly come to the third one, the reinforcement learning. Reinforcement learning means what? You know that we learned about 2 different techniques, the supervised learning and the unsupervised learning. Basically, supervised learning means we show the model the X and Y, or the responses and the label input values. And unsupervised learning, we just show the input only, we don't show the responses. Reinforcement learning means, guys, basically we don't show even the inputs. Inputs are pennanna, right? What we give is, guys, we give the particular program a kind of a goal. Abhi goal lagate hain, right? We are going to just set a goal, set a particular goal to this particular program or the agent. And guys, now the agent has a goal, and then we set, guys, different paths, different activities this particular agent can do. Who will be defining these actions, guys? By us. Api thamai design karana. Api kiyana me agent menna meya karanna puluwan, like that. Right? Agent can do these activities. As well as, guys, you know, guys, that agent is doing some kind of activity in a particular environment, right? The environment is having what? Environment is having different states. With the swabhavantina. For an example, let's say if I talk about the physical environments, you know that sometimes we may get in rain, sometimes let's say hot, sometimes let's say humidity is high. Likewise, different states are there. So now this agent has to play these actions, perform these actions in these different states. And then what we do is, guys, we ask the model, we ask the agent, under these states, under these actions, using these actions, we ask the agent to go to the particular goal that we have set, right? Whenever, guys, whenever the agent is performing some kind of a activity, right? We can't actually make this agent to go to the particular goal in a single step. It's not happening. So agent is basically going with step by step, no, towards the goal. But whenever, guys, whenever the agent is performing a kind of a favorable action towards the goal, again, goal like a desert action, goal like a yanna puluang with the action, understood? Then what happens, guys? Agent will be given a particular reward. Right? It's given reward, guys. But what happens if this particular agent is not doing the action towards or the favorable to the goal? Then what happens? We are not going to give any reward. Sometimes we can just give a penalty. Penalty means we are going to reduce some reward which was already taken. So it's something like this, guys. Then we podi kaale lamai ඔය ස්කෝල යනම කම්මලීනේ, right? සමහර කට්ටිය වැඩ කරන්නේ පාඩම් කරන්න, something like some students are say not actually studying, not actually going school likewise. Sometimes, guys, parents are giving some promises to the students. Let's say, if you pass this exam, I'm going to give you a bicycle. Or for the girls, let's say, if you pass this exam, I'm going to give you, let's say, a doll, right? When you say, when you are very, let's say now, let's say if you are going for the university, something like that. Let's say if you are going, if you are entering into the university, I'm going to give you kind of a mobile phone, something like that. Some kind, let's say, some kind of rewards are given by the parents. And then what happens, guys, that you are going to basically do the particular activity based on the rewards that you are getting. Understood? Then you know, guys, that you will be getting this particular reward if you do this particular activity only. Understood? That is the thing. Something like this. So that kind of a mechanism can also be used for teaching a particular agent to perform some kind of a task, guys. It's called as reinforcement learning, right? So that's the thing. So these techniques, guys, actually we can use for, right, teaching the AI programs to do, right, some basically some uh, right, operations, right? We can use actually for doing these operations by just teaching these stuffs. So that is what, guys, basically, right, we have to understand under this machine learning. So today actually I mentioned about basically uh, what is it meant by the AI program. I explained to you about the difference between a typical computer program and an AI program. And I discussed with you about basically the origin of the AI and these stuffs, as well as I mentioned about the agent concept. And there I explained about the single agent concept and multiple agent concept. Before that, I just introduced you about the different types of AI called narrow artificial intelligence and AGI and ASI, likewise these techniques. And then actually we came to discuss about the rule-based approach, which is the expert system concept, which is used for actually building these AI programs. And then actually we started discussing about the machine learning. And there actually I discussed with you about three types of machine learning techniques, basically supervised learning and unsupervised learning, as well as reinforcement learning, right? So these are the basically the things actually I wanted to discuss in this particular section. I hope you, right, you got a kind of a good understanding about the things I just explained to you. So so this is the thing, guys. So you have to, as I have already mentioned, this is like a very big, huge subject area, right? We have to learn. Another thing is, guys, that actually we are going to build a kind of a intelligence inside a computer program. So it's basically, right, following our human brain, human mind. So there are different. So I just explained about some simple techniques only, guys, but here we have another bigger area of this machine learning called deep learning. I didn't focus about this one under the deep learning, guys. What actually we try to do is that, in the classical machine learning, we use some mathematical frameworks and we try to map the brain function, or let's say the brain activity or the intelligence activity into the computer program. But in the deep learning, what happens, guys, the exact brain function, you know in our brain, guys, actually this particular learning thing happens based on the neurons, right? Neurons are the supportive component in our basically brain to learn something, right? If you, let's say, if you are, let's say, doing something, you constantly getting the inputs from your uh, basically eyes, ears, nose, right, your mouth, likewise. So everything is going to the neurons. In the neurons, there's a thing called dendrites, right? So I'm just talking about kind of a biological technical stuff, but I just uh, just explaining the things for your additional interest. So from the dendrites, guys, that the inputs are taken from these different things and different basically parts in your body. And then in the dendrites, it's connected with a kind of area called neuron cell. Neuron cell body is there. So, and then inside the neurons body, actually, we have a thing called nucleus, right? Connected to the nucleus, we have a thing called axon. And so what happens, guys, in this particular nucleus area, right? A kind of a chemical process is going to be happen. And as a result of that particular chemical process, an electrical signal is released from your neuron. So that is passed to your axon of your neuron and released from the synapse, right? That synapse is connected to another kind of a dendrit of another neuron. That is how, guys, these signals are moving. For an example, let's say when you are watching kind of a, let's say, a funny movie, that the inputs are taken to your body using your eyes, right? And then the things are going to your brain, and brain identifies this is something to laugh. Understood? And then what happens? Then if you want to laugh, that particular laughing, let's say that particular chemicals, hormones, enzymes should be, let's say, generated, and they should be actually connected with your mouth and your face, everything, to actually make ready for laughing. And then you laugh. So laugh will be actually released based on your mouth, your, let's say, body, face components, likewise. But guys, this particular incident will be happening with a very short time. It's actually, it's not even, we can't even count it. It's a very small time. But that is what actually happening. So if this particular same process is happening again in a particular neuron set, guys, what happens? It will be getting learned by the neuron, right? So that is what normally happening in the human brain, in the neurons. That particular neuron architecture can be, right, replaced by a kind of a computational architecture called neural network. Simply, we have a thing called perceptron algorithm, right? Perceptron is a simple mechanism of actually replacing these neurons. And then we have a thing called multi-layer perceptrons. And then, so basically those are actually helping us to deal with, right, very small typical data, numbers, likewise. But when it comes to more advanced data types, like, let's say, more advanced data types, like, uh, like images, or let's say like audios, or like, let's say, videos, likewise. These are very advanced data structures, data types that we are having. So when we have these advanced data types, guys, then we have more advanced neural network architectures like convolution neural networks. And then when we want to work with this text-like data, they are having kind of a connectivity, likewise. And then we have a thing called recurrent neural networks. And then when it comes to, let's say, now that these large language models, basically they're just dealing with very big like data, which are available in the text form. So there we use another architecture called transformer architecture. So actually that large language models are also a kind of a special type of transformer architectures. And then, guys, the large language models are also connected with some more image generation like platforms, like we call them as diffusion models, where there are some models like stable diffusion, DALI, likewise, sometimes you may have heard. And even this text can be connected with the image generation, like we call them as vision language models. So there are different stuffs, guys. And now I mentioned different advanced models like large language models, vision language models. So even, guys, those things can be performing a specific task only, because these are narrow intelligence. A single agent can perform a single task. Now what happens, guys? These agents can be connected together and create a big agent. Let's say we can just call that thing as a, let's say it's like a big agent, which is a combination of different agents, sub-agents, and it is namely working as a human. But it's not again a AGI, it's again coming under the narrow AI. That is what is called as, guys, agentic AI. That is what now actually we are talking about in the world, right? All right, so anyway, within this small time duration, guys, I tried my best, right? Tried my best, because that we have been talking about 3 hours of duration. So I tried my best to explain the things in a very simple terms. But again, I'm just telling this, guys, so this is like a motivation for you to actually, right, start your journey in the AI. Again, I just mentioned, guys, that if you want to actually explore the beauty of the AI further, and if you want to, let's say, actually learn the development of the AI, right, not using development of the AI, if you want to learn, you must love mathematics. Otherwise you will not be able to understand it very clearly. You have to definitely, right, love the mathematics, and you have to deal with the mathematics and try to understand the concepts of mathematics. So kind of advice I can just give to you as a small kids, right? So anyway, I hope now you enjoy the session, guys. So if you have any question, anything, right, you can definitely, right, contact me. I hope that you guys have my contact number. And so I think I'll show it to you again if you have any kind of uh, right uh, thing, right, to further, right, learn. I'll really happy to help you anytime. Right, this is my contact number and this is my email address. So you can reach me anytime. I'll try to, right, help you in any place whenever I can, right? And anyway, guys, that this particular webinar will be shared to you in the YouTube. I hope you have already received the links of the previous webinar recordings as well. So this one, as well as the yesterday's one. Yesterday also, I think that you had a really good session about this electronics and Arduino based thing. So right, that will also be shared to you via the YouTube. So you'll be getting those YouTube links, and then you can refer them and get more familiar with that. As I have already mentioned, we have some more sessions for you guys. One session is for the robotics, another session is going to be happened about the low code platforms. I think that we have already learned about the Python programming in the first day. So next week you will be learning, guys, how can we create the products, how can we create the softwares without using programming, basically coding, right? So again, that will be done by our side. So and we have another very nice kind of a topic called mechanical prototyping with 3D printing. So that will also be done in the coming few, right, coming 1 to 2 weeks. So your participation is very important, right? Definitely you must participate, because in the live sessions you can actually get more experience, and you can just ask more questions and get familiar with this. But anyway, if you miss anything, you will be, right, you can definitely catch it with the recordings as well. All right, guys, then we'll stop, right? Have a nice day then. Anyway, do you have any other question before we wind up? I hope no questions, right? Right, then we'll stop, dear students, right? So have a nice day, and I wish you all the very best for you all the works, and right, keep learning, and right, learn the new things, and be a challenging person, right? Okay, have a nice day, guys. Good night.